Chemistry Made Easy with Bright Edu. In today's video lesson, I'll be discussing about the differences between alkane, alkenes, and alkynes. Now you can see this table drawn on the board. I'll be using these properties to differentiate alkanes, alkenes, and alkynes. Now, before we start with the video, alkanes are also called paraffins. Okay, alkanes are also called paraffins, whereby alkenes are also called olefins. Alkenes are also called olefins, while alkynes are also called acetylene. Alkynes basically is also referred to as acetylene. Now, what is the general formula for alkanes? The general formula for alkane is written to be CnH2n plus 2. This is the general formula for alkanes. Now, what is the general formula for alkenes? The general formula for alkene is simply CnH2n. This is the general formula for alkenes. Now, what is the general formula for alkynes? The general formula for alkyne is simply CnH2n negative 2. Okay, these are the general formula for alkanes, alkenes, and alkynes. Now, let's talk about reaction with bromine water. Now, alkane do not react with bromine water. So we write do not react. Do not react. We're talking about alkenes. Alkenes react with bromine water. So alkene here is being decolorized. Alkene here is being decolorized. Okay? Same applies to alkynes. Okay? Alkynes basically are also decolorized. Now let's talk about reaction with Alkaline Kmno4, which is basically called potassium tetraoxomanganate 7. Okay, this is Kmno4, which is Alkaline Kmno4. Now basically this is called Bayer's reagent. Okay, this is called Bayer's reagent. Bayer's reagent. Now, alkanes do not react with Bayer's reagent. So right, do not react. Do not react. Alkanes do not react with Bayer's reagent. They do not react. Alkene plus Alkaline Kmno4, which is basically Bayer's reagent, when both react, it changes the color of alkene from purple, okay, from purple to colorless. Okay, from purple to colorless. It changes the color of the alkene from purple to colorless. Same applies to alkyne. It changes the color from purple to colorless. It changes the color from purple to colorless. Now, talking about the functional group for alkanes, alkanes have no functional group. So write none. Have no functional group. But talking about alkenes, the functional group is simply C double bond C. Basically, alkenes are compounds with double bonds. Alkanes have single bonds, alkenes have double bonds, and alkynes have triple bonds. Okay? Alkanes have single bonds, alkenes have double bonds, alkynes have triple bonds. So the functional group for alkyne is simply C triple bond C. Okay, now let's talk about the hybridization. Alkanes are sp3 hybridized. Alkanes are sp3 hybridized. Alkanes are sp3 hybridized, whereby for alkenes they are sp2 hybridized. Alkenes are sp2 hybridized, but for alkynes they are sp. So the hybridization for alkyne is sp. Now let's talk about substitution reactions. Now, alkanes undergo substitution reaction. So write alkane undergo substitution reaction. They undergo substitution reaction. Substitution reaction. Now, talking about alkenes, they don't undergo, so do not undergo. Alkynes generally do not undergo substitution reaction with the exception of a kind or a type of alkyne called terminal alkynes. So basically, terminal alkyne undergo substitution reaction. A terminal alkyne is simply an alkyne whereby the triple bond is found at the end of the compound. This is a terminal alkyne, and terminal alkyne undergoes substitution reaction. Now, let's talk about the degree of saturation. Now, alkanes are saturated. And why are they saturated? This is because of the single bonds. Okay, alkanes are saturated because of the single bonds. Alkenes are unsaturated. Why are they unsaturated? This is because of the double bonds. Okay, now same applies to alkynes. They are unsaturated. They are unsaturated because of the triple bond. Because of the triple bond. Now let's talk about bond angle. Alkane have a bond angle to be 109, 109.5, or that's 109.5 degrees or 109.28 minutes. This is the bond angle for alkanes. Now let's talk about the bond angle for alkenes. Their bond angle is simply 120 degree, but for the bond angle of alkynes is basically 180 degree. Okay, this is their bond angle. Now, we all need to understand the kind of bonds seen in this group of organic compounds. Now, talking about alkanes, alkane contain only sigma bond, no pi bond. So we say alkanes contain only sigma bonds. This is the kind of bond seen in alkanes. This is the kind of bond seen in alkane. But for alkenes, they have one sigma bond and one pi bond. They have one sigma bond and one pi bond. This is for alkenes. Okay, they have one sigma bond and one pi bond. How do we know? You can see we have two bonds here. So this first bond on top here is the sigma bond, but the other one here is the pi bond. That's why we say alkenes have one sigma bond and one pi bond. Now talking about alkyne, alkynes have one sigma bond. The first bond is always the sigma bond. Okay, one sigma bond and two pi bond and two pi bond. One sigma bond and two pi bond. Now let's talk about the combustion reactions of this group of organic compounds. Talking about alkanes, alkane burn with no smoky flame. Alkanes, they burn with no smoky flame. But talking about alkenes, alkene burn with smoky flame. But now talking about alkynes, alkynes burn with more smoky flame. So talking about the smoky flame, this is as a result of the carbon content in alkynes. Alkyne have more carbon content than alkene. That is why they burn with more smoky flame. Now let's talk about their reactivity. The reactivity of alkane is normal. They react normally because of the presence of the bond. But talking about alkenes, alkenes react more and their reaction is stronger than alkane reaction. And talking about alkynes, alkynes are more reactive than both of this group of compounds. Alkynes are more reactive because they have two pi bond. But looking at alkenes, they have just one pi bond. And looking at alkane, they have no pi bond. So basically, these are the differences between alkenes, and alkynes. And remember, alkanes are also called paraffins, alkenes are also called olefins, alkynes are also called acetylene. I believe now we now understand the concept about the differences between alkenes, and alkynes. Don't forget to subscribe to Chemistry Made Easy with Bright Edu. Thanks for watching.